This video discusses the relationship between rational exponents and radical expressions. A rational exponent is simply an exponent that is a fraction. There is a way that we can rewrite something with a rational exponent as a radical. A raised to the m over n power can be rewritten as the nth root of a raised to the m power. Or you could put the exponent on the inside and say that this is the nth root of a raised to the m power. I typically like the exponent on the outside, and as we learn to simplify numbers raised to a rational exponent, you'll see why. Let's start by just practicing going back and forth between the notations. We want to rewrite these first three examples in radical form. First up is y raised to the 1/7 power. Notice in that definition of a to the m over n power in our box that the denominator of our rational exponent is always the index of our radical. So the index of our radical is going to be the same as our denominator, which is 7. The base, what's being raised to the exponent, is our radicand, so y goes underneath, and then all that is raised to our numerator power. This is the 7th root of y raised to the first. Now, we could clean this up because we know anything raised to the first power is just that thing, so we could go one step further in our simplification if we chose to and said this is just the 7th root of y. Next up, we have negative x raised to the 3/5 power. Notice how that negative x is in parentheses. Those parentheses tell us that that whole thing, negative x, is being raised to the 3/5 power. Therefore, that whole thing, negative x, is going to be our radicand. And you could put it in parentheses or not, up to you. As long as you put the exponent on the outside of the radical, you could drop the parentheses. But if you are going to put the exponent inside the radical, you have to have the parentheses. The denominator of our rational exponent is our index, and then the numerator is the power that we're raising all that to. We get the 5th root of negative x raised to the 3rd. Next, we have 6y to the 2/3. So take a look at that. What is that exponent of 2/3 being applied to? Is it the 6? Is it the 6 and the y? Is it just the y? Well, this is the same as 6 times y to the 2/3. Only the y is that exponent of 2/3 being applied to. If it was both the 6 and the y, well, the 6y would be in parentheses just like it was in the previous example with the negative x. So that's not the case. The 6 has nothing to do with the radical. It's just going to be multiplying out in front. Now we want to rewrite y to the 2/3 as a radical. The base, well, that's our radicand. Our base is just y. The denominator is our index. And then the numerator, that's the power that we're raising our radical to. Just the radical, not the 6, being raised to the 2nd power. We get 6 times the cube root of y squared. Now let's go the other direction. I've given you a radical, and I want you to rewrite it using a rational exponent. First thing we want to do is identify what the base is going to be. Well, the base is the same as our radicand, which is x squared. So all of that is going to be raised to some rational exponent. I know that the index of my radical, that's going to be the denominator of my rational exponent. But what power is this whole thing being raised to? The first power. Therefore, the numerator of our rational exponent is 1. Remember your exponent rules. When you have a power raised up to another power, you want to multiply your exponents together. 2 times 1/3 is 2/3. We get a final answer of x to the 2/3 power. Let's rewrite the 4th root of 5y to the 3rd with a rational exponent. I want to start by identifying what the base is going to be. The base and the radicand are the same. So our base is going to be this whole thing, 5y to the 3rd. The denominator of my rational exponent is going to be the same as my index, 4. And then I want to think about, well, what power is this whole thing being raised to? The first. So the numerator of our rational exponent is 1. We get 5y to the 1/3 power. In this example, we have multiple things being raised to the 1/4 power. So think about your exponent rules. When the operation is multiplication or division inside your parentheses, you can apply that outer exponent to each factor. We end up with 5 to the 1/4 power times y to the 3rd raised to the 1/4 power. 5 to the 1/4, there's nothing to do with that. But look, we have y to the 3rd raised to the 1/4 power. Again, power to a power. We want to multiply those exponents. We get y to the 3/4. 5 to the 1/4 times y to the 3/4 is our answer. One of the reasons it's important to be able to go back and forth between these notations is so that we can simplify numbers raised to a rational exponent. Let's start with 9 raised to the 3/4 power. First thing we want to do is rewrite it in radical notation. 9 is our radicand, 2 is our index, and then all that is being raised to the 3rd power. Let's simplify. What's the square root of 9? 3. And then we still have that raised to the 3rd power, which is 27. 9 to the 3/2 is equal to 27. While we're looking at this example, I want to point out why I like to have the exponent outside of the radical rather than underneath the radical. Say I had done this example, but I put the exponent of 3 underneath. I'd have 9 to the 3rd raised, the square root of 9 to the 3rd. Well, first off, then we need to know what 9 to the 3rd is. $729. And then what's the square root of 729? I don't know about you, but I don't know that offhand. I hardly knew 9 to the 3rd offhand. So I don't like to put the exponent underneath of the radical because I end up getting these big numbers that are harder to work with. I would rather deal with the radical first, keep my numbers small and manageable, and I don't end up with something like the square root of 729 that I have no idea what the answer is. You certainly could go that route, you're just making it more difficult for yourself. Let's take a look at -8 raised to the 3/5 power. Notice how that negative 8 is in parentheses. That tells me that the negative 8 is my radicand, so we're going to have a negative underneath of our radical. My index is the same as my denominator, 3, and then my exponent, well, that's going to be the numerator. So we want the cube root of negative 8. Since our radicand is negative, we need to look at our index and make sure that it's an odd number. If it's an even number, we're not going to get a real number as an answer. It is an odd number, so I can go ahead and figure out what the cube root of negative 8 is. So what number raised to the third power gives us negative 8? Negative 2. So we're going to have negative 2 to the fifth, and negative 2 to the fifth power gives us negative 32. Last one, we want to simplify negative 4 raised to the 3/2 power. That negative 4 is in parentheses, so that tells me that that is my radicand. That whole thing's going underneath. Our index is our denominator, 2, and then all that's going to be raised to the third power. I have a negative radicand, so I need to turn my attention to the index. The index is 2, which is an even number. I cannot have a negative number under an even index. This is not a real number. That's something you always have to look out for. No matter what you're doing in math, you have to be concerned about a negative number under an even indexed radical.